Hello and welcome. Today we want to focus on just a little review of the goal of putting an equation into standard form. And again, standard form is a form that's really nice for graphing equations. You can find out the intercepts of of a graph really easily from standard form. And so we're going to try and get equations into standard form first right now, just by using the basic properties of equality that we've learned to solve equations. So first of all, this is what we learned about. I'm just going to go through one of these examples, but uh, I'm not sure what's going on here. But all right, so looking at this left equation, just the area of a rectangle, I want to try to solve, and if you want to do this along with me, solve for h. Okay. I know it says a equals something. We want to get it so that you can solve for h, and we're going to do similar things like that when we are making equations into standard form. So you follow the same steps, even though there's no numbers, you just follow the same steps, and you can see that this is b times h. We want to get h by itself, so we'll divide both sides. Well, we'll divide that side by b to cancel that b out. And then remember, what you do to one side, you must do to the other. All right, so h is all by itself over here, and h equals a divided by b. And that's it. You just rewrote the formula so that h equals something. Okay, we're going to do similar things to that in this short video. Before we do that, you got to know a few terms, especially the first three. We're going to be looking at a linear equation. Why we're talking about this is a linear equation. I'll show you right here. A linear equation is simply an equation whose graph is a straight line. So if you look at the word linear, you see the word line in there. Line, so that can give you a clue as to that what a linear equation is, and it's equation that has a graph, or when you graph it, it is a straight line. Right? The second term is a review term. It's coefficients. We're going to be looking at coefficients today. Those are simply the number multiplied by a variable, or the number in front of a variable, if you want to look at it that way. So if you're given the example 4x, we know that the number in front of the variable and the number multiplied by it is a 4, so that's your coefficient. The last term, we're going to skip the bottom ones, but the last term for right now are the constants. And constants are real numbers. It's a real number term in an equation. So instead of a variable term that we have variables with, this is just a real number term, so it's just a number. If you think of the word constant, it's something that doesn't change, and just a simple number won't change. So if we have the equation y equals 4x plus 2, our constant in this case, we know y and x are our variables. 4 is the coefficient. So our constant is this number that does not change, this 2. That would be the constant in that situation. So if you want to write these down and make sure you have those, you can pause the video. But I'm going to go on from here. This is what the standard form of a linear equation looks like. Okay, you'll see this form often. ax plus by equals c. You'll notice as we move on that a, b, and c are all actual numbers. But for right now, just for showing the form, it's ax plus by equals c. And you'll see as long as the x terms and the y terms are on one side, it's okay. It's in standard form. It doesn't have to be perfect like this. All right. Now, the a is, if you remember back here, is a coefficient. B is also a coefficient. C is all by itself, so it's a constant. And then x and y are our variables, and those are the two terms. The x variable is the independent variable, if you want to look back, and the y variable is the dependent variable. Okay, so that's just setting up the form. I have one example here that I just wanted to show you. It's an actual example, and this is with numbers. 5x plus 2y equals 3. That's what you'll see with numbers like that. It's in the form, has the two x terms and the x term and the y term on the left, and then the constant term all by itself on the right of the equal sign. All right, so that's the important thing there to see. Now let's try it. So it's important to note that in equation, we're putting these into standard form so we can graph them. So let's try it. If you notice this number 1 here. Number 1 says y equals 5 minus 2x. We're trying to get it into the form ax plus by equals c. So we're going to have to do some moving around, kind of like what we did with that first example in our warm-up, and also what we did last chapter. We use those properties of equality. And if you notice here, we want the two variable terms on one side of the equal sign, while the constant is by itself on the other side. So right now we have the y and the x on different sides. So what I'm going to do is and we have the constant term on the right side, but we got to get rid of this minus 2x from the right side. So what we're going to do is do the opposite of minus 2x and add 2x to cancel that out. That you have to do to the other side. And when you add y plus 2x, that's the same thing as saying y plus 2x. That's equal to 5. You can't combine those two because one has an x, one has a y. They're not like terms. So you just leave it as y plus 2x. Now if you notice, the x and the y terms are on the one side, the constant term is on the right side. So technically you're done. But technically we can write it if we want it exactly in this form by switching these around and saying 2x plus y. This would be 1y if you're wondering about what that b term variable or that b value would be, equals 5, and that would be it. You are done. It's in standard form. It only took us really one step, and if you wanted to add that last step to make it look pretty, you can. Focus on getting the variable terms to one side and keeping the constant on the opposite side. So let's try number 2 then, and I want you to try this one on your own. So if you want to pause this and try it, it says 3x minus 15 equals negative 9y. Go ahead. All right, so if you notice, the x terms and the y terms are not on the same side. So there's a couple different things you could do. I'm going to show you the first way, and I'm also going to show you the second way. There's a couple different ways. What we're going to do here is we'll leave that. So we have 3x minus 15 equals negative 9y. The easiest way to do this is just to keep this number, the constant term, on the left side and move all the other things to the right. So we're going to subtract 3x to get rid of that 3x. Subtract 3x. And you're left with here, that cancels out, negative 15 equals, if you want to look at it this way, it'd be negative 9y minus 3x. Now technically you're done. You have the x and y terms to one side, you have the constant term to the other side, so you're done. You don't really have to do anything else. If you wanted to flip the sides, you could, and say negative 9y minus 3 equals negative 15. You can do that, but this is basically what standard form is. Now those all have negatives. If you wanted to divide all of them by negative 1, you could cancel out all of the negatives and make them all positive, or you could show it this way. This is the other way that you could solve, or you could make it into standard form. So you have 3x minus 15 equals 9y, and some of you might have tried this way. Trying to get the constant, kind of like the form up here is, the constant term is on the right. You could try that way. You could say, I'm going to get rid of this constant term, this minus 15, add 15 to cancel that out, and then add 15 over here, because you have to do it to both sides, and you get 3x equals 9y plus 15. Okay, so the constant term is to the right, but now the variable term, and I apologize, this is actually supposed to be negative 9y. But now the variable terms are not all on the same side. So let's get rid of this 9y, or this negative 9y over here. So you add 9y. You add 9y. And since you can't combine these two, they're not like terms, you just leave it as 3x plus 9y That cancels out. Equals our 15. And now it's actually in the perfect standard form that we have for that formula. 3x plus 9y equals 15. It's just like ax plus by equals c. The only difference here is that the left equation has all negatives, the right equation has all positives. They are exactly the same though. If you can plug in any value for x and y, it'll come out the same. All right. So those are two examples I want to go through. I'm going to go through one other unique example that's very short, and it's over here, number 3. What you notice here is it has 3x equals 5y. And you want it in the form ax plus by equals c. So the variable terms all have to be to the same side. So let's do that. Let's just try to let's get rid of the 5y here. Get that to the other side. Subtract that 5y over here. You say, then you have 3x minus 5y. So that's good. But then this cancels out and you have nothing over there. So someone might ask, what do you do there? Well, if you have nothing as a number, that's just 0. And I never said you couldn't have your c value be 0. So in that case, it's just 0, and your equation is 3x minus 5y equals 0. It's in the form. So you are done. So now if you'd like extra practice, I'd like you to try numbers 4 through 8. All right, otherwise, enjoy yourself.